Hello students, today's topic is multi-degree of freedom system. Up till now we have seen single degree of freedom system and 2 degree of freedom system. So we know that the definition of degrees of freedom is the number of independent variables which defines the position of particles on a vibrating system completely at any instant of time. So that is degrees of freedom. So in single degree of freedom we have seen that only one variable is sufficient to define the position of any particle of the vibrating system at any instant of time, and in 2 degree of freedom there were 2 independent variables. But as the number of independent variables goes on increasing, then it becomes very difficult to form the equation of motions and form the solutions of the equation of motions. So up to 2 degrees of freedom it is possible to do it manually, but as the degrees of freedom goes on increasing, then it becomes difficult. The complexity of the problem goes on difficult, and finding the solution also goes on difficult. So in multi-degree of freedom system we take the matrices approach and try to make the solution as simple as possible. Okay, so that is why the topic of today's discussion is multi-degree of freedom system. So here we are going to see the undamped free vibrations. That means there will be only spring and mass. So we are not considering the damping system here. So we are considering undamped free vibrations. Okay. Now there are a number of examples available for multi-degree of freedom system even in the two-wheeler system. So you can make a single degree of freedom system of a two-wheeler rider, or you can make a 2 degree of freedom system by considering the mass of the wheel and mass of the vehicle separately. You can represent the two-wheeler system as a 3 degree of freedom system by considering the mass of the wheel separately, mass of the vehicle separately, and mass of the rider separately, and the different stiffness of the tire, stiffness of the shock absorbers, and stiffness of the human bones or rider. Okay, because human body also have a stiffness. It has got muscles has got stiffness. So by considering the different masses and different stiffness values, you can represent the same system into single degree, 2 degree, multi-degree of freedom system. So that is the topic of today's discussion, that is multi-degree of freedom system. Now multi-degree of freedom system, how it looks, I make a spring mass model of multi-degree of freedom system. So this is K1, mass 1, this is K2, mass 2, this is K3, mass 3, this is K4, and this is Kn minus 1, this is mass n minus 1, this is Kn, and this is mass n. Okay, so this is a multi-degree of freedom system where there are n number of masses. Okay, so each mass has got displacement x1, x2, x3, this is xn minus 1, and this is xn. Okay, now find the equation of motion is difficult in this case, but still we try to find out the equation of motion by applying the Newton's second law of motion. So apply Newton's second law of motion to each masses. Okay, so first we apply the free body diagram. First we'll make the free body diagram. So this is M1. Now this M1 is at any instant of time we consider the displacement in downward direction. So this K1 spring will try to oppose it. So its direction will be opposite to that of displacement, and its value will be K1 into X1. Now this spring K2, now we consider X2 is greater than X1, so that means this spring will act in downward direction because it will try to oppose the movement of M2, because the displacement of X2 is greater than displacement of X1, so that is why this force will be K2 into X2 minus X1. Similarly, this mass M2, will have a same force K2 X2 minus X1, but it will be in opposite direction because it will try to oppose X2 motion, and this will be K3 X3 minus X2. Similarly, this M3, it will have K4 X4 minus X3, and same way it will be M n minus 1, or rather what we'll do, directly take Mn, where this Kn is Xn minus Xn minus 1. Okay. So these are the free body diagrams of each and every mass. Now we apply the Newton's second law of motion to each masses. So this is having displacement as x1 and acceleration as x1 double dot. So this will be having x2 double dot, this will be having x3 double dot, and this will be having xn double dot. So m1 x1 double dot is equal to, so this force is in opposite direction, so minus k1 x1, and this force is in downward direction, that is in the direction of the acceleration, so that is why this is plus k2 x2 minus x1. Okay. Now this m2 x2 x double dot x2 double dot is equal to, this force is opposite, so minus k2 x2 minus x1 plus k3 x3 minus x2 m3 x3 double dot is equal to minus k3 x3 minus x2 plus k4 x4 minus x3, and in the same way it is mn into xn double dot is equal to, this will be minus kn xn minus xn minus 1. Okay, so these are the equation of motions. Now what we'll do, we will make these equations. So this will be m1 x1 double dot, we bring this values in this side, so this is plus k1 x1 minus k2 into x2 minus x1 is equal to 0. Now this is m1 x1 double dot. Now what we'll do, we try to bring the x1 terms together, so this becomes k1 plus k2 into x1 minus k2 x2 is equal to 0. So this is our equation number 1. Then this is m2 x2 double dot plus k2 x2 minus k2 x1 minus k3 x3 plus k3 x2 equal to 0. And if you take m2 x2 double dot minus k2 x1 x2 terms, there are two x2 terms, so plus k2 plus k3 x2 minus k3 x3 equal to 0. This is equation number 2. And this is m3 x3 double dot plus k3 x3 minus x2 minus k4 x4 minus x3 is equal to 0. And this is m3 x3 double dot plus k3 x3 minus k3 x2 minus k4 x4 plus k4 x3 equal to 0. Okay, so this is m3 x3 double dot. Now here there is no x1 term, so x2 term is there, that is minus k3 x2, and there are two x3 terms, so plus k3 plus k4 into x3 minus k4 x4 is equal to 0. And similarly this is mn xn double dot plus kn xn minus kn xn minus 1 is equal to 0. So this is equation number 3 and this is equation number n. Okay. So these are the n number of algebraic equations we are having. So what we'll do, we will write down these equations one more time. So what I will do, I will write down the equations. So the equations, that is m1 x1 double dot plus k1 plus k2 x1 minus k3 x2 is equal to 0. This was our equation number 1. Then m2 x2 double dot minus k2 x1 plus k2 plus k3 x2 x2 minus k3 x3 is equal to 0. This is second equation. Then m3 x3 double dot minus k3 x2 plus k3 plus k4 x3 minus k4 x4 is equal to 0. This is equation number 3. And it is xn mn xn double dot minus xn minus 1 into kn plus kn xn is equal to 0. This is so here there are n number of equation of motion. Now we will arrange these algebraic equations in matrix form. So what we'll do, we will arrange these equations in matrix form. So arrange these equations in matrix form. So the first values are, here you can see that x1 double dot is multiplied by m1, x2 double dot is multiplied by m2, x3 double dot is multiplied by m3, and xn double dot is multiplied by mn. So it will be m1 0 0 0, then 0, m2 0 0 0 0, m3 0. In the same way it will be 0 0 0 0 mn. Okay. And this is multiplied by x1 double dot, x2 double dot, x3 double dot, like that, xn double dot. Okay. So here you can see that first row multiplied by first column, so m1 into x1 double dot. Then plus. Then there are stiffness values and this displacement values. Okay. So the stiffness values are so here the coefficient of x1 is k1 plus k2, k1 plus k2. Then coefficient of x2 is minus k3, and coefficient of x3, coefficient of x4 and coefficient of xn are 0. So this is 0 0 0. Similarly, in second equation the coefficient of xn is minus k2. No, this should be k2. This should be k2. So So minus k2. Then coefficient of x2 is k2 plus k3. So k2 plus k3. So here you can see that you need to arrange the coefficient of, this is x1, x2, x3, xn. Then next coefficient of x3 is minus k3, and there are 0. Then in third equation there is no coefficient of x1, so here it will be 0. Coefficient of x3 is minus k3, so this is minus k3. Coefficient of x3 is k3 plus k4, so x3 is k3 plus k4, and this is minus k4 will be 0. And similarly so it will be in the last, it will be kn. Okay, last is kn, and this is multiplied by x1, x2, x3 up to xn, and that is equal to 0, 0, 0, 0. So this is how we have represented the algebraic equations into matrix form. Okay, so this we can write it as so this we can write it as m multiply by x double dot plus k x equal to 0. Okay. So this equation can be represented as like this. So where m, what will be the size of this M matrix? It will be n into n. So number of degrees of freedom into number of degrees of freedom. So if there are 4 degrees of freedom, then the size of this mass matrix will be 4 by 4. So this is mass matrix, and it is a square matrix. Square matrix. Similarly, the K matrix. Again, the size of the K matrix is n into n, and this is a stiffness matrix. And this is also square matrix. Okay. So in this way we have seen that how multi-degree of freedom system can be arranged into the matrix form. Okay. So thank you very much. Thanks for watching this. Thanks.